Hello and welcome back. I have this calculation that says we should calculate the mass of ammonia required to produce 3.03 times 10 raised to power 23 molecules of nitrogen according to the following equation. So we have ammonia reacting with oxygen to produce nitrogen and water, right? Now, they gave us atomic mass of hydrogen to be 1, atomic mass of nitrogen to be 14, and Avogadro's constant to be 6.02 times 10 raised to power 23 per mole. And this question is from West African Senior Certificate Examination. So let's see how we're going to go about this question. So just know that this West African certificate examination is very important for you to practice if you want to pass the currently known WAEC, right? Okay, so let's start with our equation first. We have 4NH3, that's 4 atoms of ammonia plus 3 O2 gas, oxygen, 3 atoms of oxygen gas, then 2 atoms of nitrogen gas, and then 6 atoms of what? Water, which is steam in this case since it's gas, right? Okay, so let's start the relationship now. They say we should calculate the mass of ammonia. So we are here, our concern is here to produce 3.01 times 10 raised to power 23 molecules of nitrogen. Then our next concentration should be here. Is that okay? Alright, so now let's see how it goes. Now you know that when we start this, we have 4 moles here reacting with 2 moles here, right? Are we good? 4 moles reacting with 2 moles here, right? Okay, so let's see how we go about it. Now let's find the relative atomic mass of ammonia. We have nitrogen to be just 1 atom. We have hydrogen to be 3 atoms, right? So this is going to be 14 plus, this is going to be what? 1 times 3. So it gives you 14 plus 3. This gives you what? 17. But how many moles of ammonia do we have? 4. So we have 17 times 4. This will give you 28 right down to that's 68 grams, right? So we have 68 what? Grams. Now when you come to nitrogen, now you are talking about the molecules, right? So this is going to give you, for nitrogen now, for this nitrogen gas, it's going to give you 2 moles times what? The Avogadro constant, which is 6.02 times 10 raised to power 23, right? So now since we are dealing with this, then let's relate them together. What this means is that 2 times 6.02 times 10 raised to power 23 molecules of nitrogen, right, produced what? 68 grams of what? Ammonia, right? Okay, so then what does this molecule that is given in the question, what does that produce? What will it produce? To produce what? X. Are we good? So if we cross multiply now, we have this times this, we have 2 times 6.02 times 10 raised to power 23 times x is equals to 68 grams times 3.01 times 10 raised to power 23. So since we are looking for s, we'll cross multiply by 2 times 6.02 times 10 raised to power 23. So we have 2 times 6.02 times 10 raised to power 23 times x divided by 2 times 6.02 times 10 raised to power 23 is equals to 68 grams times 3.01 times 10 raised to power 23 divided by 6.02 times 10 raised to power 23 times 2. Okay, so this will cancel this, and then we're left with x, right? So let's multiply our numerator now. So we have 68 times 3.01 exponential 23. So we're going to be having 2.0468 times 10 raised to power 25 divided by 2 times this value. Let's just multiply 2 by that value. 6.02 exponential 23 times 2 is give us 1.204 times 10 raised to power 24. So x will be, so let's divide them together, divided by the value that we have, 0.468 exponential 25. Okay, so going to be having 17. So we have 17 what? Since this is grams, we're going to be about 17 grams. So the question says we should calculate the mass of ammonia required. So to end it, you say the mass of ammonia required. The mass of ammonia required to produce 3.01 times 10 raised to power 23 molecules of nitrogen, according to this equation, is what? 17 grams. Is what? 17 grams. So the mass of ammonia required to produce 3.01 times 10 raised to power 23 molecules of ammonia is equal to 17 grams. Okay, that brings us to the end of this calculation. Bye for now. I'll see you in the next video.